Okay, today we're going to create a tic-tac-toe program in Clojurescript, and um, this time I'm going to annotate, so explain what I'm doing. All right, first, um, I have um, Clojure installed, so I have Line-Again. Line-Again is the package manager / everything else. So the Line-Again new specljs TTT. What this does is it creates a new project with the specljs template. So now if there should be a directory called TTT now, and I go in and it's all set up. So now I have a new app, and there's a few things I want to change with this. So you can see what the structure looks like. This project is just going to be a pure it's going to be a pure Clojurescript, so I can get rid of the Clojure directories. So let me do that. Spec Clojure and source Clojure. I also don't need the core spec, so I'm going to get rid of those too. So source, I guess star core star. Okay, oops. No, I think, okay. So let's see what the tree looks like now. All right, I guess let's try removing. Oh, that's because it's remove well, star core star. Okay, now I'll do the tree, and okay, so the setup looks good, and we're ready to write our first test. So just bring up the editor. GI is an alias for gvim, so I'm going to edit the spec. We'll start with the test first. And the first test we're going to do is for position. And while I'm editing, I'm going to set up the auto test. So let me think. It's Line-Again, cljs build auto. Okay, now as I save the file, it should compile and run the test. Okay, so let's start. Okay, start with the namespace. So this is position. Oh, actually, it started with TTT position and spec. Notice that the file name is _spec and the name is -spec. So when you have a Clojurescript or Clojure file and you name it with a dash, it gets converted to an underscore. So just remember to do that. Otherwise, you'll end up having problems like things not being recognized. Okay. The next thing is I need to do my require. So this is a spec, so I need to require the macros. Now this is different from Clojure because you have to require macros separately from the regular stuff. Okay. Okay, so macros from specljs core. I'm gonna grab the describe context. It should equal. That's a good start. We'll probably add more if we need to. Then we need to require specljs core, so this way our spec will work. And we'll need position and take the first thing that we're going to implement is init position. So since I'm going to be typing init position probably a lot, I'm going to make that into an abbreviation. So IP as init position. So now I type IP, and if I press escape, it does that. The other way that I could do it is I press Control right bracket, and it does that. Another way is if I type IP and space, then it does that. So many ways. Okay. All right. So it's set up, and I write my first test. I have ulti-snip set up, so I can type DE, and it sets up my describe. Okay. Position. My context. The function is init position, and what should it do? It gets the initial position. Okay, again, position is something that I'll probably need to use a lot, so I'll just make that into an abbreviation as well. P as position. Okay, so now it's like, there it is. And our first test is should equal. Okay. Let's see. So this is the expected part. Okay, this is, I'm also going to make this into an abbreviation because like I'm probably going to use this a lot. So board and turn. The board, it's a map, so that here's the board, which is square bracket. Okay, just set of dashes, and then you have the turn is X. That looks good for the board, and I sometimes use another board that's filled in, so I'm going to do that. Okay, so that looks okay. Okay, so back to this. It's board and turn. Okay, so that's what it should look like. Oops. And for the initial position. Now, initial position I am going to set as a variable, so instead of a function. So this way, there's no parentheses around this, so I'm not calling it. So I'm ready to run this test. I save, and it takes a little time, but the auto test is picking it up, it's compiling it, and it should throw some errors. And it has a little bit of a misleading error message because it says, you know, it was successful, but really what happened is the JavaScript didn't compile, and so there was nothing to run. So there's 0 examples. Okay, so let's look at the error here. Okay, it's a two-step process. It has to compile it and then run the test. And running the test, it's just looking for the JavaScript file. Okay, so let's see. It says could not find position, TTT position. That's because we didn't create it. So we'll create one. So edit source cljs TTT position. CLJS. Now since I'm working with two files, I could have split the file and go back and forth, but I'm doing it a different way. Now if I press Shift Control 6, I can toggle between this and the other file. So it's a very quick way for me to go back and forth. All right, so let me see. Okay, so I'm doing initial position. So first thing I do is the namespace, TTT position, and let me just do def init position, and let's set it to be just empty. Now I should get back an error message, but a different error message because now the file exists. Great. So you can see that it actually ran a test. It found my test because this time it got compiled. Okay, so what we need to do is we need to make this look like this. So one way to do it is to cut and paste this whole thing and just, say, yeah, this is what I want. But instead, I want to make this program a little more general. General meaning that, like, I'm going to say, here's my dimension, it's 3, and my size is going to be dimension times dimension, so there's 9 pieces, 9 places. The reason why I'm doing this is because if I want to make a 4x4, all I need to do is change this to a 4 and everything should work. So that's my goal. So here's my initial position. I have to fill in the board and the turn. So for the board, there's a function called replicate. And I could do this many times, and it's going to create a list. And I'm going to fill it with dashes. Okay, so that should take care of the dashes. Then for the turn, it's going to be X. All right, so save, and now it should pick up. Let's see if it passed. Okay, it passed. I didn't realize that what was going on because of this dot. I don't like the way the output looks. So let me change this. So if I go to the spec runner, I'm going to pass in reporters and say that I want documentation. Okay, and I have to restart, so it'll pick up the change. Okay, so how did I know that it was reporters and documentation? Well, specljs doesn't have a lot of API documentation, so I had to go in and grab the source code and look through it. Okay, so it's actually waiting for a file change. So let me just trigger a file change. Okay, so now the result looks a little better. It says TTT position, init position, gets the initial position, and it's green. Okay, great. Let's go make our second test. Okay, so okay, good, back and forth. Okay, so our second test is going to be move. Oops. Context. It's going to be move. It makes a move. Okay. All right. Okay, so I'm going to modify this, but I'm going to make a move the initial position 0. So when I make a move on position 0 over here, this is going to be an X, and it's going to be the other guy's turn. So it's O. Okay. Oh, one more thing about this is that this is a vector. And here, when I do replicate, this returns a lazy sequence. And that'll cause problems a little bit later. And really what I wanted was this to be a list, a vector. So I'll just convert that into a vector. So now it's a vector. And if I save, it should still pass. Okay. Right now, this is complaining because I don't have move. Okay. I was expecting that error because I didn't do anything for the move. So let me just go back in here, and this time it's a function. So defn move. It takes a position. Okay, I'm gonna do a deconstruction. So okay, position index. This is the way the parameter looks, but I'm going to deconstruct this, and this is going to be a map of board and turn. So what I do is put it in curly brackets and say keys. The set of keys is board. Actually, we don't need turn, so I'm just going to just say board. And if we wanted to, if we wanted to refer to the whole thing, we can just say as. And position can refer to the whole hash map, and board is going to be the deconstructed value of the board. But for now, I'm not going to do that because I don't need to refer to the whole thing. I just need the board. Actually, I do need the turn, I realize, because I have to change the turn. Okay, so I'm going to return just an empty hash. This is just to make the compiler happy. And now we can see that this is what we want, and this is what we have. We need to turn this into that. So there are two sections. There's the board and there's the turn. And let me just put okay, I'm just going to put something bogus so you can see what it looks like. So you can see that it's slowly turning into that. So here's board and here's turn. Okay, it's expecting O, and for now, like if I, okay, it's a symbol O, so that's why I put a tick over here. I don't want it to be evaluated. Otherwise, if I did this, it'll think that O is some variable and it'll try to evaluate it. But I don't want it to evaluate. I just want it to be treated as an O. Okay, so for the board, all we want to do is change one of the values, and you can do that with a sub. Okay. So we have the board, and what do we want to change? We want to change index, that index position to be turn. So whoever's turn it is, if it's X's turn, we're going to fill it with that X, and then O is going to be the other person's turn. So let's see. I'm expecting this to pass. It's compiling. Okay, and it passes. So I hard coded that O, but okay. Actually, this should really be makes a move for X, and now this one's for O. Okay, so actually X and O. So I'm going to change this so that from here like this. So move of the initial position 0. So X makes a 0. So I'm going to make another move. Move from this position 1. So what I expect is the O to be here and the turn to be back to X. Right. Save, and this should fail. So we always start with a failing test. Okay, so the only difference now is that it failed because I hard-coded the O. So what it really should be is I'm going to call this a function called choose. And based on the turn, if it's X's turn, you're going to choose to return O, otherwise X. So I'm going to write that. Choose turn X and O, the X value and the O value. So if the turn is X, then I want to return the X value or the O value. In this case, I swapped the return values because I want to alternate the turns. Okay. The reason why I'm doing this is because choose is going to be used in other functions, so I just broke it out. Okay, everything passes, so we can okay. I don't need to use choose here. So okay. So we have move passing. Next thing is let me just add it over here. Possible moves. PM. So possible moves. Okay, start with the context. Possible moves. It lists possible moves for a position. So let's take a look at this. Okay, this is the other position that I set up. So given this position, it starts from 0. That's 1. That's 2. So the available position is where the dashes are. So let's see. That's 2, 3, and this is 6, 7, 8. 6, 7, 8. So that's what I should expect from this position, but I have to call possible moves on that. So possible moves of this. Okay, so I'm going to start. Okay, I know that I was expecting that error because I didn't define it. Possible moves, and I'm going to do a deconstruction. So colon keys, board. Let's see, no, I don't need to know what the turn is, so I'm just going to keep board, and I don't need the whole position. And yeah, that's it. Okay, so let me just save, and okay, so it got nil because I didn't put anything in here yet. So let's do this incrementally. So let's start with the board. Okay, so what we want to do is we want to turn this into that. There's a function called MapIndex. So what this does is it'll take each of the cells, so like for example the X, and instead of passing into map just a cell, it'll also pass the index position. So if I created an anonymous function over here, %1 is going to be the position, %2 is going to be the cell. Okay, it's going to be useful. So what I want to do is if it's a dash, that's an empty cell of %2 because that's the cell. Okay, if the cell is a dash, then I want to return the %1, the index position. Otherwise, nil. Now, for this, it automatically returns nil anyway, so I don't really need to do that. So now I save, and I should be one step closer. Okay, there's a problem, and the problem is undefined is not an object, map index. Oh, that's because I made a typo. It's indexed. I should have realized it when the syntax highlighting didn't change. Okay, so we're really close. So we have 2, 3, 6, 7, 8, but we have all these nils, and we need to remove the nils. So we can wrap this and say remove and give a predicate, which is a test for nil. And it passes. Okay, great. So we're off to the next one. Possible moves. The next thing is win. This is a test to see if somebody won. Okay, win. We'll start with the base case, which is okay. That to be determines, because I'm going to say determines a lot. So it determines no win. Okay, so what position doesn't have a win? The easiest one is the initial position. So Okay, instead of using should equal, I'm going to say should not. This will look for a false, or nil or false. So should not, actually I should be wrapping this as a function, should not, and the win of the initial position for x. So it's going to test for to see if x won, and this should return false. Now this is going to throw an error because, okay, let's see what the error is. It throws an error because I didn't include should not. So let's go to the top over here. I'm expecting the compilation to return a whole bunch of stuff, and you can see that the error is something is not defined, and that's should not. Remember, this is being compiled into JavaScript, so that's why it's an underscore. Okay, so should not. Okay, unexpected. Win. Oh, right. That's because I didn't write the win. So now we go back to our source and stub that out. Win, and it takes. Let's see. What do we need? We need. We deconstructed keys. We need the board, and we don't take the turn. The turn is going to pass in as the second argument because we're just looking at the board, not whose turn it is. Okay, so let's see. Okay, so for now, let's just leave it like this. And this will return false every time because it's nil, and it passes, which is good. It's a good start. Usually we start with the failing test, but this is the base case, and this will fail. This will fail because when we do later tests, we're going to be adding code in there, but we want to keep this as a sanity check. Okay, so let's do another test. It determines a win on first row for x. Okay, so this time we use should win, and the position is this for x. Okay, and we're going to fill this in, but we're going to do a little bit more some cutting and pasting. Okay, we need to do. Okay, so the way that you win is if you could win from the first row, second row, or third row, and then you can do it by the columns or diagonally. So let's modify this. So x, x, x. Okay, so now we have that, and we just changed the labels. This is the second row, and this is the third row. Okay, and we just keep everything the same. This one is going to be the column, and let's just to test for the other one. This time we'll make this an O, and we're looking for an O. Okay, and because this is done by columns, it's best if we just make it look like this. Okay, and we need 3 of these. So this is 1, 2, 3. We make a fourth one because for the diagonals. So this is the first column, second column, third column. This one is going to be the diagonal. Okay, so we have 8 cases here, and using some Vim tricks, Control V, R, O, and just using dot to replay that. Okay, so now I do the diagonals, change the label instead of saying, I guess I could keep it, but major diagonal and minor diagonal. Okay. All right, so let's run this. And I should have a bunch of failures. And it's failing, obviously. Actually, Why is it failing? I thought it was because when is not defined, but something else is not defined. Oh, should. Should. So I have should not over here, but I do not have should. Oops. Okay. So let me just do that and include should. Okay, now it should look better. Okay, so we have 8 failing tests. We went on first row, second row, then we have the columns, then the diagonals. Okay, let's do this. So here we need to make a just to make it convenient rows, and there's a function called partition which groups it together, and I could say group it by my dimension, the board, so it'll break it up into 3 rows. So this does it automatically, so I don't really have to do a lot of coding to get this. And another good thing is to have a function. I'm only going to be using it here, so I'm just going to make an anonymous function called line match. And function, it's going to take in a line, and it's going to return. The test is if every one of these are put a hash here. Okay, so if every one of the arguments are equal to the turn, that is my test for the line. Okay, so this looks good, and I'm going to say sum line match rows. So I have 3 rows, and if any one of them has a line match, then that's considered a win. So let's check. Okay. All right. So the first one failed. That means that I have something wrong in my logic. Okay. It's interesting that, So, given the line, every term is equal to it. Okay. This is interesting. Why did it fail? All right, so let's go back and take a look at the test. The test looks okay. First row. Okay. All right. Rows. So one way that I would debug this, well, this is what I'm doing right now, is for the first test, I can't really see what's going on. So I like to use my test as sort of a debugger. And I would say should equal nil when initial position, actually not the initial position, but maybe this one. Yank that. Okay. And I should wrap that in an it. Okay. Test. And okay. The reason why I'm comparing it to a nil is because I know this is not going to return nil. And I just want to see what the output is. Oh, okay, so here it is, nil, but got returned a function. Oh, that's really interesting. So that means that this is returning a function rather than a Boolean expression. Okay, so let's, oh, Oh, that's because I put the hash in the wrong place. Because this line match is actually returning a function instead of evaluating it. So when I do this, this makes this whole thing into an anonymous function. And if I do it this way, then it calls it. And this is the anonymous function. This is what I wanted, and I made a mistake. So now, if I save, let's see. No, now this is more of what I expected. So my initial test failed because I made a failing test just because I wanted to see that the answer is supposed to be true, and it is. Okay, so we can get rid of that test. Okay, and it is what we expected because the first rows are passing. The first row, second row, and third row. All right, so now we want to make the other thing pass, the columns. So here's a quick trick. We need to transpose the rows. So instead of getting going across, now we want to flip it. So easy way is to transpose. And to transpose, it's apply map vector. This is more like an idiom. So you just have to learn this. And if you have time, you could, figure out how this actually works. And it's pretty simple. Okay. All right. Now we have to wrap this in an OR. Okay, great. And now I'm expecting the columns to pass, and it does. Now we need to make the major diagonal pass. So for the major diagonal, okay, so this is what I mean. So now we're expecting this to pass once we make some changes to the code. Okay, this time we don't have a set of rows, we just have one line because the major diagonal is just one line. So we're just going to call line match directly. Line match, and we need to have a list of indexes. So it's going to start from 0 and go all the way to the end, right? I'm just writing this piecemeal right now. Okay, so it's going to start from 0 up to size, but not including the size. The size is 9. So it's going to go from 0 to 8. Size is 9, so range doesn't include the end value. And we need an increment. The increment is the dimension plus 1. Okay, and you can think of this as, if you have 7 days a week, adding 7 to a day is going to be the next week, but the same day. But if you do 8, then it's going to be 1 day shifted over. So this is what we want. This gives us a list of indexes, and what we need to do is turn these into cells. So we have to add the anonymous function here, which is oh, actually, we did it. We do want to do the line match. Let's see. Right. Okay. So this it takes in a line. All right. So we need to convert this into map. We need to convert them into cells. So we have the index position, and so we need to say get position %. Okay, so that takes the index position and looks it up and returns the cell. So let's see if this works. Okay, it's compiling. All right, so let's see. Interesting. Oh, I didn't save this. Okay, but it's still failing, and it's still getting a false. Actually, maybe I removed that testing a little bit too early because I want to see what's going on here. So for actually line match. Let's try to figure this out logically. So line match expects a set of cells, major diagonal. Okay, so here's the set of ranges, increment, dim, position, get. So now I have a list of cells, and this calls line match. So this looks like everything should work, but I am getting a false. All right. Yeah, yes. Let's take a look at let's see. Okay. Okay, I'm gonna yank that and paste. Okay, so my test, it returned false, but let's see what the data looks like. Okay, I'm gonna just take that out. Okay, the test, nil, nil, nil. Okay, that's not what I expected. Okay, the reason why is because of position. I didn't mean position, I meant board. Because board is the one that holds the array, and position holds everything. So let's write that. Now let's take a look. Okay, so this is more of what I expect. O. Okay, great. So that is the correct behavior now. So let me go back. And the only thing that's okay, so now I can get rid of the map. Okay, so line match. Okay, line match. So I can just throw it back to line match. Okay, so this is great. This is exactly what I expected. This was just for debugging. I have this passing. Now I need to get the other thing to pass. Okay, so all right. So let's go to the test. I'll just leave that there and get rid of it when I get the other thing to pass. Okay, so all right. The logic is going to be very similar. Okay, so the only thing that we need to change are the range. So instead of starting from the upper left, which is position 0, we're going to start from position 2. 2 happens to be 1 less than the dimension. So it's decrement dimension. And we also don't want to include the last item because what's going to happen is 0, 1, 2, 3, 4, 5, 6, 7, 8. So here, it'll start from 2. If you add 2, it'll go to 4. If you add 2, it'll go to 6. And if you add 2, it'll go to 8. But we don't want to include the 8. So here, we're going to decrement the size. So we're not including the 8. And the steps that we're taking is 2, which means that we're going to change this to a decrement. All right. So let's see if this works. And it works. Great. So now we just get rid of this debugging information over here. And everything passes. Okay, so this handles the position, and this is it for this video, but I'm going to do the next video on the next module, which is the engine. So see you in the next screencast.